All right, we're going to do investment word problems. And the reason we're doing them is because they are based with logarithms and exponents. And they're used all the time in real life. And so here's a real life application of when will I ever use this? There you go. So as we look into these, there are two formulas, compound interest formulas, okay? After T number of years, the balance, which is represented as A, in an account with a principal of P. P is the amount you deposited, okay? The opening amount you put in the account. And an annual interest rate of R, okay? That's important too, and it will be in decimal form, is given by the following, okay? So all these variables. TAPR. For n compoundings per year. Okay, I'll explain that in a second. But here's the thing. The balance equals the principal, which you put in originally, times 1 plus the rate divided by the n number of compoundings raised to the n number of compoundings times the time. Now, thank God we have calculators to do all this for us. So the problem is going to give you much of this information. Now, what you need to know for n, it's going to be given to you in a word like monthly, weekly, quarterly, biannually. So n is per year, okay? N is talking about time in a year. How many times in 1 year? All right. So if it's monthly, how many times would it compound interest? Well, there's 12 months in a year, so n would be 12. If it's weekly, how many times would it compound in a year? Well, there's 52 weeks in a year, right? Quarterly, that means just like 4 quarters in a dollar, there's 4 quarters to a year, so n would be a 4 if it said the word quarterly. Biannually means twice a year. That prefix bi means 2, so 2 times a year. So look for those words in the problem because that will tell you, if you see any of these words, that tells you you're using this formula, and it also tells you what value you're putting in for n. Now, if the problem doesn't read like that, if the problem says it's continuously compounding, then we use a different equation. Notice this equation has A, P, and RT. There's no n value in this equation, so you don't have to worry about the number of times it compounds in a year because it's continuous, right? And you'll find out that the continuously compounding are the ones you really want. So P is still principal, R is still the rate, T is still the time, A is still the balance in the account. All right? So write those formulas down. I will be giving you the formulas. You just have to know how to use them correctly. All right? So let's try one. Number 1, $1,500 is invested into an account at an interest rate of 2%, compounded continuously. How long will it take for the money to double? Now, the fact that it says compounded continuously means I'm using this formula right here. All right. Now I need to find my values. I call it the Pratt method. Okay. Principal. What's the principal? The amount I initially deposited in my account. Well, that's $1,500. The rate. The rate's given to you as a percent. I have to write it as a decimal. So 0.02. A is the balance in the account. Well, what does it say? It's asking us how long will it take for the money to double. So what's double 1,500? Multiply it by 2 and you get $3,000. Time. That's the question. How long is time? That's what I need to find is the time. So what I'm going to do is put all these values in my equation. So I have 3,000 equals 1,500 times e to the 0.02 times time, which is what I don't know. Now, we need to solve this. All right, don't stress out about the exponent just yet. Let's isolate the e to that power first by dividing by 1,500. So I will get 2 equals e to the 0.02 t. Now, just like before, when we converted exponents to logarithms, okay, so when we did converting, we didn't talk about natural logs at that point. So let me just kind of pull back. Before we said log base a of b equals x. We could convert that back to an exponent saying a to the x equals b, right? But what if it's a natural log? Okay, natural log of a equals x converts to an exponent by swirling. Remember the base. It's e to the x equals a. So now, we're in this form over here on the right. I need to move it back to the natural log form because notice the exponents are gone now. And that's what I want. So, what am I going to do? Natural log of a, which was my answer, so this is natural log of 2, equals x. Well, what was x? X was the power of e. Alright, now we have it in an equation without exponents. We need to isolate t for time, so I'm going to divide by 0.02. Alright, and you'll use your calculator. There's a natural log button on the calculator. We'll find it when you get to class. You'll hit natural log of 2 divided by 0.02, and when you do that, you're going to get approximately, it's all approximate, 34.7 years. That's how long it would take for the amount to double in my account. Okay? Want to round to the nearest tenth, by the way. All right, let's try this problem. $2,500 is invested in an account with an interest rate of 3% compounded continuously. How long will it take for the balance to triple? Okay, keyword. Continuously tells us I'm using this equation as opposed to the other one. So let's figure out our Pratt values. Principal was $2,500. The rate, 3% as a decimal is 0.03. A is the account balance. Well, what am I looking for? It says, ask me how long it would take for it to triple. So 2,500 times 3 quarters is 75 cents, so $7,500. Time is the unknown. So it's going to look much like what we just did. So let's put our values in. 7,500 equals 2,500 times e to the 0.03 times time. Okay, the first thing I need to do is isolate the e, so I'm going to divide by 2,500. I get 3 equals e to the 0.03t. Now we need to get it out of exponent form into a logarithm form to get that t out. Okay, remember what we said before. If it's a natural log, base e of a equals x. If we convert that to an exponent, it looks like e to the x equals a. Alright, so we're reversing the process. We're going this direction. Okay, so let's think. Natural log of a was 3 equals, now e is gone, so it's whatever x was, the power, 0.03t. I need to isolate the time, so I divide by 0.03. And again, you're just going to type this in the calculators. And when you do, I get approximately 36.6 years. Okay, round to the nearest tenth. That's how long it would take to triple my money. All right, that's a really good interest rate, by the way. 36.6 years to triple my money. Not bad. Let's try another one. $8,000 is invested into an account at an interest rate of 2.5% compounded weekly. What will the balance be after 30 years? Okay, so this is different. This is compounded weekly, which means I use this formula with the n. Okay, and let's see what our values are. Okay, so this is Pratt and same Pratt values, but now we have an n because it's compounded weekly. So principal, what's the amount we started with? $8,000. The rate, there it is in percentage. I need to move that decimal over 2 places, so it's 0.025. The account balance, okay, that's what we need to know. It's asking us, what's the balance going to be after 30 years? We don't know that. That's the unknown. The time is given to you in years. It's 30 years. And n, okay, how often is it compounded? Well, weekly. Again, how many weeks in a year? 52. So we put a 52. So let's just see what happens. A is our unknown. So let's plug this in. 8,000 times 1 plus 0.025 divided by 52 raised to the 52 times 30 power. Right? Now, if I plug all this in the calculator, be very careful when you do that you put appropriate parentheses and use fractions appropriately. We can talk more about this in class when you have your calculators. But what I did was type it all in, and guess what I got? I got the new balance will be $8,002.98, which is a rotten deal. Think about that. After 30 years, you made $3. Not a good deal. So compounding weekly, not as great a deal as you think it is. Okay? Let's try another one. $2,000 is invested into an account with at an interest rate of 1.85%, compounded biannually, so twice a year. How long will it take for the balance to triple? All right, so again, since it says biannually, not continuously, I use this equation. So let's find our Pratt values. P is principal, so how much should I start with? 2,000. R is the rate. Well, here it is as a percentage, and make it a decimal. Move that decimal place over, 0.185. A is the account balance I need. Well, I need it to triple. So 2,000 times 3 is 6,000. The time is what's asking me, how long. And N, how often is it compounded? Biannually, which means a 2. So let's plug this in. 6,000 equals 2,000 times 1 plus 0.0185 over 2. Raise to the 2 times t power. All right, this is a little trickier because your t is up here in the exponent. So what do? Again, we want to get rid of the 2,000 first. So I'm going to divide both sides by 2,000. I get a 3 equals 1 plus over 2. All of this is raised to the 2t power. Now, I need to rewrite this in logarithm form. Notice there's no e, right? There is no e, so this is a common log, so we can go back to this. Log base a of b equals x. Remember to go back and forth. That would swirl and give me a to the x equals b. So we're in this form right now. I need to go backwards. So I can use a common log because there's no e. So I'd say log base, what's the base? All of this mess right here, which I'm going to go to my calculator and figure that out. 1 plus 0.0185 divided by 2. If I do that in calculator, I get 1.009, just for now. So that's my new base, 1.009. Okay, power, so if I, my base, so A is my base, I figured that out, of B is the answer, right? So B is my answer, so B was 3, equals, and then the power is what it will equal, so the power comes down to 2t. Now, I can put all of this in the calculator, okay? You go to math, the math button, and you go to the up arrow, and then there's a log base function. You can type this in just like this. You'll have to enter the base, and you have to enter the 3, and it will give you the value. Okay? And when I do that, when I do all this, okay, I get 122 point, I'm just going to do 62 for now, equals 2t. So I need to divide by 2. So t turns out to be 61.3 years. Okay? 61.3 years is how long it would take to triple the balance in my account. All right? So this is a little trickier. You're going to want to follow this example as you work these problems if this is the way your problem reads. Okay? So remember the rules of converting logarithms and exponents. That's really, really key to this problem and the previous ones. Okay? So refer back to this as you need to. Okay, I'm not going to do any more examples here, but we'll do some in class, so come prepared for that. Have your notes ready.